Dear students, hello! We have not met for more than a month, and now I would like to record my lecture on the subject of theoretical electrical engineering. It is the first lecture in this semester, used to be. I have read it already, but we have not met more than a month, and I would like to repeat this material for you, for those of you who have heard it, and for those of you who have not heard it, and I think that it will be a nice thing to listen it one more time and to remember what is it. So let's start. This semester material will be about transient processes in circuits, and at first we will consider such a processes in linear circuits with lumped parameters. What is linear circuits? Linear circuits it is circuits which elements, namely resistances, inductances, capacitances, does not depend on levels of the applied voltages and levels of current which flow through these elements. What means lumped parameters? Let's consider at first case when applied electromagnetic field has length of wave which is much bigger than linear dimensions of the elements from which these circuits are consisted. And when we consider case of application of so-called power frequency, it means 50 Hertz, length of such fields is comparable with radius of our Earth. So we may presume that in each point of the considered schematic, even it is we consider, for instance, power transmission lines with rather big lengths of about many kilometers, all the same length of applied electromagnetic wave will be much more than linear dimensions of this circuit. So we may consider that in each point of the considered electrical circuits parameters of electromagnetic waves are the same. In such a case, we can consider that these resistances, inductances, capacitances may be presented as lumped parameters, not distributed when length of electromagnetic wave is less than linear parameters of circuits, and in two different points of this circuit, we may obtain different levels of electromagnetic fields. And now we'll consider transient processes. It is not like it was in previous semester when we consider stationary processes and with no change of elements, of regimes of operation. Now we consider switching processes. Any change in operation mode of a circuit, or any addition or destruction of some elements of circuits it may be considered as switching. And these processes are very important for operation of electrical circuits. And in some cases, these switching modes are just regular modes of operation, and so they should be considered. It is It is agreed that switching occurs instantaneously, and time instant at which they occur is considered equal to 0. So we have t equal to 0, it's moment of switching or commutation. It's the same terms of the same event. And there are considered several modes of operation of the circuit. First, it's t less than 0. It is a steady state processes in the considered electrical circuit that existed just before switching. Before switching, it was T regime in which considered circuit works before switching. Then let's consider moment t equal to 0. It's moment of switching. And this moment is considered from both sides of this t equal to 0. First, it's t equal to minus 0. It's the very last moment before switching. And second, it's t equal to 0 plus or plus 0. It's the very first moment after switching. Then let's consider time period t greater than 0. It's just at a mode after switching when transition processes occurs. And at last, when t tends to infinity, it means that steady state processes after commutation and after transition processes ends is considered. And we should remember that certain electromagnetic energy conditions, which cannot change instantaneously, correspond to each state of a circuit. And what it means that electromagnetic energy, which is connected with flowing current through inductance, and it is energy of magnetic field, cannot change instantaneously at t equal to 0 at the moment of switching. The same refers to electric field energy. It's due to application voltage and storage of charge in capacitance, and this energy also cannot change abruptly, it will change smoothly just before commutation at the moment t less than 0, and at the moment t 0 plus just after commutation. And theoretically, transient processes last indefinitely, but in reality, voltages and currents stop changing practically and retain their volumes the same as in a steady state regime just in a fraction of a second. And we will consider only such a period. I will show you. We will consider period of this period t greater than 0. It will last for a period during which maximum levels of currents and voltages will be less, equal or less than 1% of maximum level at the beginning of switching. So, at first we will consider the so-called classical method of transient processes calculation. And this method supposes solution of linear differential equation that describe investigating circuit operation after switching. And from mathematics, it should be known to you that solution of differential equation may be presented as sum of two components. It is a particular solution, you see, sorry, it is a particular solution, and it is general solution. Particular solution of such equation presumes solution with assigned right-hand side, and general solution correspond to solution with zero right-hand side. So we can write down, for instance, for current during transition processes, you see here is small letter I, it means instantaneous volume of current, as sum of forced component, it means particular solution, and natural component, it refers to general solution of the considered differential equation. So forced correspond to steady state response of current. Here of current, it may refer to voltage also, and it is caused by presence of the external sources of electromagnetic energy in the circuit after switching. So it's caused by equation's right hand side. And forced component occurs immediately after switching, and it remains in a circuit after transition processes ends. Form of this component depends on the character of electromagnetic energy source. If such a source is a DC electromagnetic force, its EMF, and when it is direct, the forced component is also DC. If EMF, which is connected to the considered circuit after commutation, is AC, force component will be AC also. And if after switching, considered circuit is disconnected from the source, then forced component will be equal to 0. You should remember that forced component is determined just by the character of the source which will be connected to the considered circuit after commutation. And natural component, you see, we got this component for the case of zero right-hand side of the considered equation. So it's just free component, or it is called also transient response, for instance, of current, but it may be voltage also. And this component exists only during transient processes, and it decays this time in all real circuits, and this is due to presence of active resistance of this circuit. So this component will be equal to 0 when we consider mode t tends to infinity. This natural component arises because sometimes we have inconsistency between amount of electromagnetic energy, for instance, energy of magnetic or energy of electric field, and inconsistency of such an energy at the very last moment before switching, and the energy amount at the very first moment after switching. And why it is appear? Because we have forced component which will last during all period t greater than 0, and as it was not before commutation, after commutation it appears, and to compensate it, this natural component arise to make smooth transition of magnetic or electric field energy during this commutation at the moment t equal to 0, t of energy from the moment t minus t equal to minus 0 should be equal to energy at the moment t 0 plus. And form of these natural components, it depends on the number of reactive elements in the circuits, and it coincides by order of the solving differential equations. And if you have two reactive components in the circuit, for instance, inductance and capacitance, it will be second order differential equation which describes such processes. And if it is only one reactive element, it will be first order differential equations. And this natural component does not depend on the type, character, presence or absence of electromagnetic field source. You should remember it. It does not matter what source will be connected, DC, AC, or no source will be connected or disconnected during these switching processes. And for describing this natural component, the so-called integration constants are used to depict this natural component, and number of these integrations constant equal to number of reactive elements. If there are two reactive elements, inductance and capacitance, it will be two these integration constants. If one, it will be one integration constants. And to solve such a problem solution, I mean determination of these integration constants, we will use initial conditions which may be depicted with the help of switching laws. And these switching laws based on energy conservation principle. And now let's start considering these switching laws. Let's consider this switching law or switching rules, it may be called also. This switching law, let's consider first switching law or switching rule. It arises from the conservation energy, and it is due to the fact that if energy change abruptly, not smoothly, it will require infinitely large power to support such a processes, either of magnetic or electric field energy, and it is physically impossible. Therefore, electromagnetic energy always changes smoothly, because if this derivative of energy dV by dt, dW by dt equal it is not changing smoothly, it will require infinitely big power to such a processes. So